Before anything moves, something must turn. Every machine, every turbine, every clock that measures time itself begins with one perfect rotation born from steel. Inside this factory, motion isn't accidental. It's engineered through equations, heat, and pressure. Raw metal arrives in long bars, their density logged, their composition analyzed, each one destined for transformation. The air vibrates with a constant hum. Conveyors, presses, and cutting heads working in perfect synchronization. Each rotation you hear hides thousands of calculations: torque, friction, tolerance, stress. Nothing is decoration. Everything is precision. Even the silence between machines has rhythm. Beneath all this noise lies a deeper truth. Motion is not chaos, it's controlled geometry. To violate one rule is to collapse an entire chain of movement. What turns the world is not raw power but perfect accuracy. In the next section, watch how raw metal learns to move for the first time inside the fire that defines its future. Inside the forging hall, temperature climbs past 1,250 degrees Celsius. Bars of steel soften under gravity, glowing bright orange as the furnace breathes compressed air through its core. Each stroke of the hydraulic press lands with the weight of 10 tons, shaping the circle that will become a gear blank.
Where motion begins.
Steam collides with sparks. Air pressure pulses through the chamber. Molten scale falls like rain. Operators track temperature and pressure simultaneously. Deviation beyond 1% triggers immediate recalibration. Every blow is a calculation in metallurgy and time. When the die closes, the air vibrates with energy. In that instant, form replaces chaos. Strength is not born from heat alone, but from measured control under pressure. The metal now carries memory of force, of direction, of resilience. But raw strength without guidance means nothing. In the next stage, you'll see how geometry begins to carve order into power, where steel meets mathematics. The forged blanks cool under sterile white light. Precision begins as the CNC machines lock each disc into place, aligning its center within microns of perfection. A high-speed cutter engages steel shrieks, coolant floods, vapor rises. On the monitor, digital readouts flicker. RPM 1,450. Feed rate 0.02 millimeters. Tool temp 68 degrees Celsius. Every tooth profile follows an algorithm derived from torque equations. Sensors analyze vibration at 2 kHz intervals. The system self-corrects in milliseconds. The sound is rhythmic, mechanical geometry becoming reality through rotation. Nothing escapes measurement. Even the tool wear is predicted before it occurs. The result, each tooth identical, each void equal, an architecture of motion. Yet even perfect geometry can collapse under heat and time. Up next, you'll witness how fire hardens this delicate order, turning symmetry into endurance. Heat treatment begins, where form ends and structure begins. The gears enter the furnace, sealed in nitrogen atmosphere to prevent oxidation. Temperature rises from 850 to 1,000 degrees Celsius, carbon atoms migrating deep into the steel lattice. The glow changes from red to brilliant white, a signal that the internal grid is locking tight. At the peak, the tray tilts. Each piece plunges into quenching oil. Steam explodes upward, lighting the hall in silver mist. The transition takes seconds, but defines the entire lifespan of the gear. Inside, martensitic transformation begins. Steel realigns on a molecular level. Sensors record cooling curves, ensuring hardness meets design. 62 HRC on the Rockwell scale. Surface stress is balanced. Edges remain intact. This is the science of permanence motion, forged to resist time. But strength without harmony fails in silence. What follows is the stage where perfection is sculpted atom by atom, where motion is quiet enough to be heard. After fire, silence returns, but it's the silence of precision. The grinding wheel spins at over 3,000 revolutions per minute, diamond grit removing layers thinner than a human hair. Sparks spiral like fine threads of light, vanishing in a mist of coolant. The scent of steel and oil fills the air. Motion becomes measurement. Laser sensors project a red grid across each gear tooth, mapping microscopic deviations. The data feed shows profile error 0.002 millimeters, run out 0.004 millimeters. Operators watch without emotion. Perfection is routine here. Every sound is analyzed, vibration peaks, trimmed until waveform amplitude disappears. When grinding stops, the gear reflects light evenly across all teeth, symmetry achieved. And yet, even this silence must still prove it can move. In the next phase, you'll see how every piece meets its counterpart, testing whether rotation itself can be flawless. After every tooth is ground, measured, and verified, the gears are finally brought together. In a clean testing chamber, two freshly finished gears meet for the first time. Their contact is recorded by high-speed sensors, measuring vibration at 10,000 samples per second. The rotation begins slowly, a faint hum, a flash of light reflecting off polished steel. Each gear tooth slides perfectly into its counterpart. The sound is uniform, a signature of precision where friction has been mathematically erased. On the screen, a live graph plots resonance amplitude, flat, steady, silent. Deviations above 0.002 millimeters trigger red alarms, but the line stays green. A robotic arm applies load torque, mimicking years of operation in a single minute. Still, the movement remains smooth. Engineers call this moment the mesh. It is where geometry and reality meet, proof that precision has purpose. But perfection means nothing until it moves beyond this room. The next sequence shows what happens when these gears leave the factory, when their rotation becomes the heartbeat of the world. From the factory floor, the gears travel into the machines that shape civilization itself. In an automobile gearbox, they translate combustion into motion. In a wind turbine, they transform the invisible force of air into power. In a watch, they divide time with silent precision. Each rotation echoes the calculations forged within this factory, every turn a continuation of geometry and control. No part moves alone. Every motion depends on another, each gear's tooth aligned in an unbroken chain of design. Under microscope inspection, the surface of a single tooth appears flawless. No tool marks, no fractures. Yet, what matters most is invisible. The balance between torque and resistance. The science of rotation without error. Around the world, millions of gears turn this very moment, unseen, uncelebrated, but essential. They move aircraft wings, surgical instruments, satellites, and ocean turbines. This is engineering, stripped of emotion, reduced to pure law, where the difference between silence and chaos is measured in microns. The camera returns to a single gear, spinning slowly in darkness. Reflection of white light forms a perfect ring across its edge. Because in every machine, in every movement, in every revolution, precision isn't a choice. It's the only way the world turns.